very good. Well, I'm Len KD0RC, and today we will talk about a little gizmo that I built called the Teensy Maestro, and there's a couple of examples here. This is the first time in history that more than two Teensy Maestros have ever been in the same room together. So this is the original that I built that you'll see some pictures of. This is the one that Simon built. This is the one that I built based on Simon's board. So we'll talk about all that in a minute. So what is it? Well, it's a home brew device that gives me knobs, buttons, this little touch display that I'll show off in a minute, and CW memory here, and it works with Flex 6000, 8000, and Aurora series SDR radios. So there's the Flex radio right here in the flesh, and it operates in conjunction with, not instead of, the Smart SDR software that normally runs this radio. It will also work in conjunction with a real Maestro, which is, I'll have a picture of that in a minute too. It uses a little teensy 4.1 board that is like an Arduino. So if you're familiar with an Arduino, it's like that, except on steroids. It's much smaller, much cheaper, and much faster, and has a lot more features. It's programmed in C++ a la Arduino using a library that I found on the internet from IW7DMH. Enzo Stefanazzi in Italy built this fantastic library, and that's what I use. I would not have had the knowledge to do what I did if I didn't use his library. So that was really great. Now, these things connect to the radio using Ethernet. They do not connect to the radio using CAT commands and USB like you're probably used to. So it's a whole different mindset how you program something to work with this. I can connect remotely to this with this to a radio somewhere else, but it does require a VPN. And so, Mark, when you were mentioning that, you can't just automatically get this to go hook up to the club station. So, Mark, you and I will talk about whether or not we want to put a soft ether VPN up there, and how we'll do that, and keep it separate from the other computer that runs the monitor.
And there is a zero-tier VPN now.
Yeah, there's many. I've made this work.
We have.
Oh, we have one already. Okay, maybe that's what we'll do then. So I have had this working with soft ether. I have not tried zero tier, so we can. Okay. Anyway, that's for another day. But anyway, so that's what this is. It just gives you knobs and buttons for a radio that's just a little plain on the front. Oh, there's a picture of it. All right, so this is how you normally connect with a flex radio, either the Smart SDR operating on a laptop or a computer, or a real Maestro. And this is mostly really cool. Now, with this, you have the ability to operate using the computer and the Teensy Maestro at the same time. So when you're tuning a station by, pointing and clicking, sometimes that's the right way to do it. It's just easier. So you can do that. Other times, like if I'm in a contest or field day or something, and I'm just working station after station after station down the band, I really like the tuning knob for that. And so then I do that. In almost all cases, I prefer to just turn these knobs for volume and the AGC threshold, the filter widths, and high cut, low cut, that kind of stuff. CW speed. I don't want to have to click around somewhere to find CW speed to slow down for a guy or speed up whatever I want to do. I just want to spin them up. So there are what I considered the most important features that I wanted to see is what I designed into this. So how do you build this thing? Well, I bought this Flex here in February of 20, and I found that Arduino project by Enzo, and by May of 20, I had ordered the parts that I could find and discovered I couldn't keep going. All the parts, not all, half, 3/4 of the parts were now unobtainium, especially the display. And so I thought, oh, no worries. I just bought other similar parts and I'll just adapt the software. It was then that I realized that he had not provided the source code for the box that he built. He only provided the library. So I was stuck. So I thought, well, another start and forget project. So I said, well, I'll just fool around with some C++ that I didn't know. I don't know COBOL, PL1, Fortran. Yeah. So, yeah. So C is not, that's a foreign language, but I kind of learned it. And I played around with a Arduino DUI that I had, and I actually got it to connect to the Flex. And that's all I wanted to do. I just wanted to see if it was even possible. So I thought, well, I wonder, I have these encoders. I wonder if I could get it to change the volume. Well, I got it to do that. Next thing you know, I was adding controls, and I wound up with a working set of controls for the radio. And so you can see I built it into a cardboard box as sort of a prototype, way to prototype it. I had decided that I would need a bunch of LED indicators to show me what I was changing. Like, how else are you going to know? And tons of buttons to do stuff. Well, it didn't take me long to realize I had made some really terrible design decisions. First thing, I ran out of Arduino GPIO pins for all the encoders, buttons, and in this case, it took a big board, an Ethernet shield, they call it, to add Ethernet to it, and that burned up half or more of my GPIO pins, general purpose IO pins. And I wasn't going to have room for all the LED indicators or anything. Second bad design decision I made was that I built this little matrix. So if you take rows and columns, and wherever they cross, you connect them with a button. And so if I have 5 rows and 5 columns, I can have 25 buttons, and 5 rows takes 5 pins, 5 columns takes 5 pins, so it's a total of 10 pins, gets you 25 buttons. I thought that was a pretty good deal. And the first few that I wired in this way were pretty easy, so I moved on to what the next problem was, so I'll come back and fill that out when I get time. Anyway, I thought I had it, and I didn't. The rat's nest of wiring, I just couldn't get any more pins. As soon as I soldered one, it popped another one off. I couldn't make it work. I also used 10-inch header pins instead of soldering to the proto board, and we'll talk about that board in a minute. The board was a good decision. That cleaned things up nicely, but pushing header pins on everything made unreliable connections. It was great for prototyping, not so great for a unit that I was carrying to field day and everything else. So if you haven't figured it out yet, I'm not an electrical engineer. So here's something, the Flex community. So I started looking and asking for help on the Flex community and got what I needed. So John from England, G3WGV, answered some questions I had, some general questions, and that got me going in the right direction. And then, most critically, he steered me towards the use of multiplexers for the buttons. Well, I didn't know what a multiplexer was. I'm not an engineer. But once I figured that out, I got the ability to address 32 buttons using only 7 GPIO pins. And this thing is currently using 20 or 21 buttons. But even that, if I had it to do over again, which thanks to Simon, I did have it to do over again. We used a different kind of multiplexer that used only 2 pins, and it shared 2 pins that are already in use, so it didn't cost me any pins. And that really made the difference. So then moving down, Mike, Tim, Eric. Tim is the Tim that you're talking about, Mark. That's Tim Ellison. They jumped in on a couple of my questions and really got me fixed up very quickly. And that's where I always say reading the documentation and understanding the documentation are 2 distinctly different events. I had read it all, and I misinterpreted some things. Once those guys got me straightened out, I started making progress on this thing like crazy. It's life in general. But then the fun part, for those of you who've ever had a job, you know that scope creep is always a bad thing. Can't have any scope creep. I had that beat into me from my junior programmer days until the day I retired. Well, screw that. I like scope creep. So I scope creep this thing like you wouldn't believe. The company PJRC came out with that Teensy board with the built-in Ethernet. Well, that gave me back a bunch of I/O pins, a much easier interface to deal with. Everything was better. So I pulled apart that Arduino mess, rebuilt it using the Teensy 4.1. Almost all the code ported over with no change. I had to make some very, very minor changes to accommodate a different library for the Ethernet. And then while I was making things bigger, better, I took the color TFT screen off this other start and forget project I had, and immediately got relief from having to worry about all those LEDs showing individual things. And if I ever added a feature, am I going to start drilling more holes and adding more LEDs? Not likely. So the TFT screen, color touchscreen, really made a huge difference. So here's a picture of the Arduino, and it's the Arduino on the bottom with the Ethernet board pushed into it on the top, eating up so many of my precious I/O pins. And then you can see that I have wired in almost all of the rotary encoders, but I only have very, very few of these, maybe 4 or 5 of these connected to the switches. It was the switches that were so hard to deal with. And that's the little matrix board you see at the bottom there. Another problem that I had with this was you see there's a row of resistors next to the wires. The Arduino Due was notoriously bad at providing pull-up voltages for the push-button switches. So I had to add pull-up resistors. Something happened. Okay.
Sorry.
Oh, is that you?
Yeah, I'm just trying to make it bigger.
I asked him if he could zoom it to full screen.
It's all Mark's fault.
I saw setting out when you were there before. You want to think full screen at the bottom. So do you manual?
Yes. Oh, there we go.
Bueno.
Thanks, Mark.
Okay. Good. Okay. So this was just, I couldn't proceed with the project with it like this. So much more better. I put the Teensy board. That's the little Teensy 4.1 board. And there is this is the display that I took off of the keyer that I was building that I never really finished. And then this is one of the multiplexers, that little red board. Is my mouse showing? Oh yeah. Okay. Yeah. That's the little multiplexer. And this is the Ethernet. So this started working really well right off the bat, and I realized this was gonna work. So some of the building techniques that I use, this is something that you can buy from Adafruit. It's designed so that it works just like a proto board that you plug into, except you solder to it. That way you can set up your circuit on the proto board and transfer it to this more permanently. Well, I didn't do that. I just used it because the spacing was perfect for the Teensy board, and it gave me two power rails, power and ground rails, as well as five connections. So 4 additional connections for each pin that I could connect buttons and knobs to. And then the front panel, and it's this one here, is really just a piece of plain typing paper put through a laser printer, and I printed just exactly what you see here, and sandwich it under a piece of ABS plastic I bought at Ace Hardware for like 30 cents. It was much harder to cut that plastic out than to deal with it otherwise. Anyway, that's how I kind of built it and got it to look reasonably good without having, CNC shop or anything like
An
that.
engraver.
Yeah, no engraver. And we'll talk about that in a minute because the guy did that.
Oh, nice.
So one of the things that I discovered was that the layout that I originally put together that seemed so logical to me, I caught myself grabbing the wrong knob every time. And I realized that's an indication that my ergonomics are really not very good. So this one is the semi-final version of it. And, I had now, this is another cardboard front panel, by the way. And I finally got it to where it was almost the way I needed it. I only had to swap 2 controls after this particular iteration. And then here is what I call the semi-final layout, because even after this, I've added controls. So you can't have enough scope creep. So this now has the keyer in it. It's got a CW speed. It's got, 2 different receive tuning, volume for each side of the radio, AGC threshold for each side of the radio, the high and low cut or width if you're on CW, and it switches automatically back and forth between the two. And you can see here where I have the keyer, straight key paddles. And now what I also have added here is a switch that lets me switch between 2 microphones. And when you switch microphones, you have to reset things up audio-wise, right? And that's a pain in the neck. On the Flex, it's not too terrible because you set up a profile for each microphone, which I had. Well, now when I flip this switch, it physically switches a different mic to the radio and sends a signal to the radio to say, give me the other mic profile. So
Cool.
it's totally automatic. Really, I'm spoiled. I spoiled myself with this thing. Well, then this Kiwi guy from New Zealand shows up. That's Simon right here, NB0E. And he said, oh, that's really cool. He said, I just built a sprinkler controller for my house, and I did all the boards and software and everything for it. He said, I'd like to do the boards for your Teensy Maestro. And I said, no way, Ron. I said, oh yeah. And so this is what he came up with. They're absolutely brilliant. So he found a cheaper and better touch screen than I was using. So this is half the cost, or less than half the cost, because it contains an integrated touch controller, and mine has a separate touch controller. He found cheaper encoders, and the boards were very reasonably priced. So here's the front side of the board with all the encoders and buttons and everything on it. Here's the back side with these are now multiplexer chips instead of those multiplexer boards. And a socket, nice socket for the Teensy Maestro. And then he socketed all of the external connections. So any of the other buttons or anything that you want to connect to it is all connectorized. So it is so easy to make this the way you want it.
Plus, it's a work of art.
Yeah,
Yeah, it's
did.
gorgeous.
Yeah, just unbelievable.
Yeah.
Unbelievable. So here's the front panel, and there's an example over here that you can look at after the presentation. And you can just see how beautiful this is. So this is in aluminum, but you can also buy it a little bit cheaper in FR4 printed circuit board, and it looks pretty much the same. Now, kits and boards. Everybody asks me about a kit. Are you going to have a kit? Well, I am not going to do a kit. That's a lot of work. But Neil, G7 UFO in England, went ahead and once Simon came up with the board, he asked if it would be okay if he created a kit. And I said, absolutely. So he's doing a kit. And then Bill, K9HC, out of Katy, Texas, is offering full board sets, much cheaper than you can buy them. Because if you get these from JLPCB, JLC PCB, you have to buy them in lots of five. And they're a little bit more expensive. Bill has a business, so for him, he buys in bulk, he buys them 50 at a time or something, and can sell them much, much cheaper. I don't know what his cost was. I'm going to talk to him at Hamfest this year and find out. He told me that he is planning on providing full kits, which will really be cool. But I haven't heard more on that yet. Bill gets distracted and whatever his project of the day is where he's working, so I may have to prod him a little bit. So here's my camper. This is the dinette in my camper, in which you can see here's the Flex just sitting on the seat with a CAT 500 tuner and a KPA 500 watt amplifier sitting on top of the Flex. Here's my computer. This is a phasing noise reducer. And here's the Teensy Maestro. So this was Field Day 2021. Had a great time. Using the Teensy was great. The keyer in it works really well. And it was just a great experience. And this is what it looked like. I'm not going to go through all this, but you can see I just put a mast up on the back. I mounted a couple of aluminum mounts to the back of my camper, and I can put that mast on in just a few minutes. So how do I do remote operation with this? Well, at my home station, I have my computer running Smart SDR, running soft ether VPN, some utilities. These are now mostly replaced with utilities that I wrote. And then there's the amplifier, the tuner, the Flex, my tail twister rotator, then out it, and then of course my modem out to the internet. Then in my camper, I have another computer that I'm running Smart SDR, and I have a Wi-Fi connection to a hotspot out to the cell service and in. Then the Teensy Maestro uses VPN to connect to the local computer, and through all that, it's as if it's connected directly to the 6400. And that's what Mark and I will talk about in terms of getting something like this available to use with the club. By the way, this is not a big line plug. That's paddles.
Oh.
It wasn't until I gave this presentation at another meeting and somebody says, well, what do you plug that thing in?
220 no less.
Yeah.
Those Arduinos, boy, they really are.
Yeah.
They suck some power, boy.
It's a big gun.
Yeah. So there's a bunch of other known Teensy Maestros in the wild. My buddy Dave, W4WKU, some of you may have known him as KG0EW when he used to live over here in Louisville. He built the second one. And then all these people, got Steve, who was living in Texas at the time, Ben in Hong Kong, Lassie in Sweden, Stan in Pennsylvania or someplace. All these people, Stefan in Canada, Bill in Queensland, Australia, and so forth, all the way down to, and here's Neil from England, some French, Germans, Portugal, And this guy doesn't look like it, NB0E, but he is from New Zealand, so. So here's Dave's. This is in his handband that he built, and you can see it here. He's just got paper labels on everything at this point, and now he has built one so it looks like Simon's and my new one. He bought the boards and stuff and built himself a new one. He took a lot of the stuff off his old one and built the new one. And here's his handband with his thing, and I don't know who that idiot is there looking in the door, but anyway, that's his handband. Here's Steve's. Now, what Steve did, he ordered from Front Panel Express an etched, engraved, and color painted thing. This front panel cost him over $100, probably $130.
Wow.
But it's really beautiful. But he did make a mistake. He put the labeling. I carefully moved the labeling so it would never be obscured by a knob. He didn't think about that, and even though I had provided all the spacing, he moved his stuff too close, and the nuts on the buttons overlay his beautiful engraving. That other than that little minor issue, it's a really good looking setup. Here's Ben from Hong Kong. He developed the first boards for this, but never shared them. And then he built this in a much bigger enclosure. I don't know why. There's no reason to have that much room on there, and it takes up so much desk space. But that's what he did, and he built two of these, one for himself and one for his buddy in Hong Kong. Stan, K3PW, built his out of this is 3D printed. So you can kind of do your own thing. Mike from England didn't want all the knobs and buttons, so he only built essentially half of it. So he's got the A slice, and the B slice just stays blank. And for most of us, that's the way we operate a lot. Don't always need two receivers cooking at the same time. The only thing that he did that I didn't care for was he put the labeling on the knob. So when you turn the knob, the labels turn upside down. So I didn't care for that. But his idea of putting this in a really tiny little case was really cool. And you can see it in his operating position. It's a nice looking little unit. Here's Thomas from France, did the same thing, but in a slightly different way. He built a really nice looking one, again, with only one knob, but he added all the other knobs, just only one tuning knob. Perfectly good design decision if that's how you want to operate it. This is Neil G7 UFO, and this is the kit that you can buy from him. And he also 3D prints this, but then he laser etches the front of it. So it looks really, it doesn't look 3D printed, it looks really nice. He shared some pictures of his initial ones where it was just kind of rough, and that already looked really good. And then this goofball comes along and designs this really nice front panel and board set. And that's this to me is the best looking one. So thank you. Nicely done, Nate. All right, you can build your own. I provide a user manual, a builder's guide, a complete bill of materials, and Simon does the same. So if you want to build it point-to-point wired, you can. If you want to be smarter about it and use the boards that Simon designed, he's got the same things out on his site. There's a schematic, front panel layout. It's all on two GitHubs, Simon's and mine. And there's a thread on the Flex forum that you can keep up with it. So if you ever decide you wanted one of these, you have a Flex radio. And by the way, these only work on Flex. So don't think this is going to work on another radio. It's very strictly Flex. All right, so let's get to any questions and then we'll start a demo. So, yeah.
I noticed there wasn't any RF gain or volume, AF volume.
There is AF volume. Mhm.
I have an RF gain.
Not on the box, no. RF gain, you don't need to adjust super often on a flex. This is not your dad's radio here, right? This is a pure SDR, and
If you want to set it like right at the noise threshold, one of the cool things. Can you do that easily? I mean, that's-
well, you don't do it. No, you don't do it that way. So is that all shown? Okay, good. On a flex radio, I don't want to get too into this. See, here's the RF gate. What you do is you set it so that the noise floor without an antenna is 10 dB lower than the noise floor when you have an antenna. And all that does for you is give you the highest dynamic range that the radio is capable of, which is about 100 dB. Right? So you're not adjusting it for noise like you would think. On the other hand, there is a control here. It's not labeled well, but I do have this on the front panel. And this is the AGC threshold.
Yeah, okay.
Right. So they teach people, and I don't like this, but I'll tell it to you anyway. They teach people treat the AGC threshold as if it's an RF gain, but it really works differently. So actually don't do that. I can see why people think that, but what you're doing here is you adjust this value so that if it's all the way up, your AGC threshold is way down here in the noise. And that means you're amplifying all this noise at the same rate that you're amplifying your signal. So you want to raise that up so that you're just over this noise, which for me at my location tends to be somewhere in the 33, 34 range, somewhere in there. It's not critical. So I have it hovering somewhere above the noise, and you just listen to it. And when the noise suddenly backs off of there's a little bit of a knee where the noise goes down a little bit faster than the movement of the knob, then you're at about the right place. Then you've reduced the noise to a much more manageable level.
It's once you have that.
Well, once you do it,
It's like, what? Where is it on the other radios?
Right. So
Len,
you have to think of it a little differently. Yeah,
do you run it with the AGC on or off? That meter?
on, always on, always on, because the amplification, I can control the amplification of noise with it on. With it off, I cannot. And you're always amplifying all the noise the same way. So always on. One thing I will say, they give you fast, medium, slow, and off as choices. Off is just there, I think, to make people feel good that they can still do what they used to do with the radio, but it works so differently. I know of no reason to turn it off. Right? In older radios, there were reasons to turn it off because AGC pumping, right? Things that would happen that in a superhet radio that do not happen on a flex. It's just a totally different animal. So I have no reason ever, and I can't really feel much difference between fast, medium, and slow. On my K2, if I set it to fast for CW, man, it's jumping around. I almost have to have it on slow.
Yeah,
It drives me
I
crazy.
use it on fast all the time. I like the way it sounds, but that's maybe
Yeah, but
you're right. I guess I really never thought of that.
yeah, it doesn't, but you can run it wherever you like it, but I haven't found that it makes much difference, so I just leave it on medium and it seems to keep me okay. All right, so other questions and then I'll start demo. Yeah,
For us who are really, really new, what does SDR mean?
okay, we're gonna talk about that in a minute. SDR is software defined radio. And I'll give you just a precursor to what that is. And then at some point, I put together an outline that we haven't quite talked through yet how we're gonna do it, but to do some training, that will give you a much better idea of what that means. But what it basically is, if you take the RF spectrum, and so for a flex, that's 60 kilohertz to 60 megahertz, right? That's a lot. It takes all that information, all those radio signals, and it goes through and it digitizes every however many fractions of a byte of a hertz, all the way through that, and it turns every RF signal into a set of numbers. And then everything else happens in the computer, and the FPGA, which is a field programmable gate array. It's basically like a computer and like a piece of hardware all together. So you can make that hardware do whatever you want or act like a computer. In any event, that's what gives you that wonderful PANADAP, right? So that's all numbers, and then at the end, it goes through the reverse process and gives you audio back out. So you start with analog, go to digital, do nothing but computations to make it, turn it into sound, and then at the end, back into actual sound. So
Flex radio is separate port radio.
what's that?
The flex box is a separate port box, or can you build one of them?
Oh, no, these are only available for sale as built. Yeah. They don't, there are no schematics available. There are no, not much else.
Yeah, like my wife says, I'm technologically challenged, so.
Yeah. I'll say this about Flex, even though I'm wearing a Flex shirt, I got this at Hamvention last year. You were right, Jim, I loved it. That was a great time. I look like I'm selling Flex, right? My wife embroidered my claw on my Flex
You have
hat.
the tattoo yet?
Huh?
Do you have a tattoo?
Well, I can't show it yet.
Thanks for that.
Well, I can't. But I actually will always tell people, it's such a different experience that it's really not for everybody. And and the nice thing about the club is you can use that radio and try it out and say, well, that's awful. And don't waste your money on one. Or you can start hooking up with it like Mark and say, dang, gotta have one. And that's what I did. So I went to HRO and spent, well, hours and hours over a couple different days down there. 99.9% sure that I was going to buy either a TS890 or an IC7610. Those were my two choices. And neither one of them had that gotta have it vibe. I was like kind of disappointed. So I asked my buddy Dave if I could come over to his shack and just spend an hour or two mess with his radio and see if maybe that's, well, within a half an hour, I was sold. He didn't have to say a word. I just said, okay, I can get along with this. And off I went and bought a Flex. The rest is history. Okay, other questions? All right, let's demo this bad boy. So everything.
Hey, Len, I have one.
Yeah.
If you buy one of these kits and put it together yourself, what's the approximate cost to do that?
Oh, what did Neil was selling his for around 400. That's 400, yeah. But then he dropped the cost at the end and to about 300 maybe, 280, 300, somewhere in there.
Okay.
But now if you buy the parts yourself, you're going to be in the 350, 400 range probably. A Maestro these days is 1,500 maybe more.
1,600.
Yeah.
Which is Flex Radio's front. It looks,
Yeah.
it's got the knobs on it.
Okay. Yeah. Okay. Is that showing on the screen? Okay. Staying in focus. Not very well. Okay. Oh, we don't have much light.
You turn the lights on?
Just the one set here.
This is the Stealth Teensy Maestro.
There we go. Oh,
Okay,
that's perfect.
that's better.
Thank you. Oh, a treasurer who's a hardware guy can flip a light switch?
I know, it's, jeez.
Multi-talented.
Okay, I was hoping we were gonna have some more signals. I did hook up an antenna, or Simon did. Obviously did it wrong because we don't see any signals. But you can see how it tunes. You see how when I tune the knob. This was one of the hardest things I ever had to do on this. If you look at how this, see how fast that goes? Or I can tune it very, very slowly.
Nice.
So I built the acceleration in which Yaesu radios do, and not too many others. That was brutally difficult. It was 2 years, or more than 2 years, 3 years before I was able to actually get that to work. But here's your volume. You can see the volume knob move on the top there as I turn it. Here's the AGC threshold. I can turn that up and down. I can turn mute it, unmute it, right?
So I noticed it clicking. Is that your shaft encoder?
It's two things. So the shaft encoder itself does make a bit of noise. You can hear that a little bit.
Yeah, I thought I heard it.
But there's actually a click that you can turn on or off.
Oh, so it's off, it's just software.
It's both. So, and so let's look at the software. So here's something else to understand about a flex. I can create a new slice. You see how it popped up on the screen? And I can tune that one separately. Okay. And that's really, I love that aspect. I've done myself in again. Finding the, there's the picture. Okay. There. Sorry. Okay. So next, let's look at the menuing system. I would like to know what you said. Sure, go ahead. Use slides. Does that mean that instead of taking data from 16 kilohertz with this, the 16 years, you'll actually only take data between the slides, lower frequency and upper frequency? Yeah. And then we'll put it in. Yeah. So when we do training, I'll get more into the terminology, but a slice is just a receiver. Everybody thinks of it like a VFO. So if you're used to a radio that has multiple VFOs, you have one VFO or the other active. You have one on receive, one on transmit, you split, right? Love all that stuff. Well, this is actually two independent receivers operating at the same time. And it's just what you say, it's a slice. They call it a slice because it's taken just that 3 kilohertz or whatever slice out of the spectrum. And so somebody coined the term slice, and that has of course confused everybody because it's really a receiver. But we get the reference that it's a slice of the spectrum. Yeah. Okay, so here's the menuing system, and I'm not going to go through every single one, but I'll just rotate through them a little bit. Here's the CW menu, and one of the things that this has is CW memories, and each of these 12 items on here is represented across these keys. So, right, so I can send CW just by pushing the buttons, and then what's here that's editable on the SD card, which you can get to the SD card from the computer, and I can change these to whatever I want. So I can change them on the fly. If I'm out on field day, I have a different set than if I'm on the 160 meter contest, and so forth. This is just some that I have for general use, and you can just push the button, or I can dial them in. You probably can't hear it. I can hear it up here, but anyway, so forth. Let's see. I have the ability to have multiple stations connected, and I can tie the Teensy to whichever station is connected to the thing. At the moment, there's only one, and that's this laptop right here. If Simon were to be logged in, I would see him on here as well.
So is there a small speaker in the Teensy for?
There is.
Okay.
Now, one of the things that I need to do, and I've said this for only 4 or 5 years now, I need to add a little amplifier to it. It's too weak. You don't normally need it because there's a side tone in the radio.
Yeah.
And this has 2 methods of keying the radio. If you happen to be in the same room as the radio, just run a cable from the back of the Teensy to the key jack here and operate it that way. If you are remote, I have an option here. And it says, you see where it says output local. I can change that to be output Ethernet.
Hmm.
And now, if I were to do that, it will actually send it over the Ethernet and transmit. Now, that's a difficult thing, because think of all the latency that happens over the internet.
Yeah, absolutely.
Yeah. So Flex came up with a method, and this took me forever to get right, but I was the only one to get it for a while. And then all these other guys came out with keyers and other stuff and used what I did here to generate their stuff, which I was pretty happy about. And then, it was finally, people are able to get remote key that's reliable. And Flex had it all along, they just don't advertise it very well. And so I asked some questions, and Eric Waksman from Flex finally gave me the right answer, and I got it working. So I'm really happy about that. Let's see, other stuff that's here. Here are all the memories, so I can change memories real quick. Here are a bunch of miscellaneous things. One of the things that the Flex software doesn't have is if I have 2 slices open, how do I clone one to the other, right? The A to B button that we all love. Well, they do it on their Maestro, but they don't do it in Smart SDR. Yeah, there's no.
See, I'm using the Mac software, and now I'm trying to think.
And he's got it.
Yeah, I was gonna say,
Yeah.
I was like, I think he does have.
Yeah, he does have it. So I have A to B and B to A. I'm shortly going to change that to left to right, right to left, because on the newer version that I'm working on right now, it's going to allow you to have more than 2 slices. Not on this radio, because this radio only supports 2, but I have an 8600 at home that supports 4. And so I want to be able to do that. So you can see some of the stuff, VFO acceleration, I can turn on or off, and I have an acceleration factor. So some people want it faster, some people slower. You can use the SD card to do that, or change it right here in the menu. Let's see, here's all
Can you
my.
do manual acceleration? Like you just press a button?
No. No. And here's all my profiles that I keep. And then how I can do things with CW, where I can use the message source. So if I push one of these buttons, it says Teensy here. That means I'm going to get the messages stored in the Teensy. If I change this to Flex, see now it says Flex. If I push this, whatever the corresponding Flex memories are, is what it will
Very
do.
Amazing.
Not bad for a rookie, huh? Okay, and then we're back around. Now I have several other menus that I have available. There's some filters and things like that. So if you have a reason that you wanted those, you can, on the SD card, you can turn those on or off. And for my personal use, I leave them on. Now here's another feature that this thing has. If you tune this thing out of band. When I get low enough here, there. Look at what it says, out of band. See that? Every time I move this, it's warning me. Oop, oh no, it's warning me that I'm out of band.
Yeah.
And so it has it set up so that you can have, you tell it what license class you are, and you see it on the Teensy Maestro, it turned it red, and it has my license class of extra listed here. So you can, I set mine to be extra because that's my class license, but you can set it to novice, technician, advanced, your general advanced, and extra. Somebody in Australia, Phil, an Australian VK4KW said, "Oh, what about us, Mike?" I said, "You're right." So I made that more generic, and while it's, you just go into and edit the SD card, tell it what license class names you have, and then their position on my little chart of frequencies, and you can adjust that chart for whatever you want. So you can make your European, Australian, even New Zealand, however you want, and it'll be accurate for you.
Is that just a text file?
It is.
Right.
Yeah. So the SD card looks like this. You can edit the SD card from the computer, which for some reason I can't do right at the moment. But what it looks like,
So are you bypassing the flex band plan? Don't they have some of that in?
no. All I'm doing is that's an excellent question. I'm not.
That's always been an annoying thing is
Yeah.
they're very strict about.
Yeah, you can't, so here's here's the band plan. Okay, so I do for just, I only broke it down by CW and phone. If anybody had a burning need for it, I could probably do more, but I find this is good enough. And
But you could just redo one of those if you wanted. I mean, right? You can just edit it.
well, this is all editable.
Yeah, exactly.
But it doesn't give you any more rights in the radio.
Yeah, exactly.
All it does is give you display warnings and changes the color of the display. So, and you can see all the things. It'll also do spots. You can see I can put, like, I have all the W1AW bulletins in here. So that and the reason I put that is not because I'm going to go listen to the W1AW bulletins. I've done plenty of that for code practice, but there's always this nice strong signal. That's W1AW.
Yeah.
So if I have it listed there,
You can jump over and hear what the band sounds like.
well, no, then I'm not going over trying to work them.
Oh.
Yeah, because otherwise I see a strong signal. Oh, yeah. Oh, that's W1AW. Yep.
Yeah.
So things like that. And then there's a FlexNet every Sunday morning. So I put that on there so I can see it. So
So those show up on the screen then when you're tuned to those frequencies?
they can,
Cool.
and they're clickable.
Oh, yeah.
Oh, nice.
Cool.
Yeah. And now I have another utility that I wrote that I'm not going to go through today, but that is called Flex Repeater Spots that will also change modes and add colors and do all kinds of other things. But that'll be for another day. Okay, questions? Okay. Yes.
Connected by Ethernet to your computer, then the computer to the flex, or are you connecting it directly to the flex?
Directly to the Flex. So the way it works, the Flex is the server. Smart SDR is a client. My Teensy Maestro is a client. All right. Simon Software is a client. The Smart SDR is a special flavor of client called a GUI client In other words, it's bringing back all the waterfall and everything and the audio. This is a non-GUI client and it's only providing control.
So does that mean that I could use that on a Mac?
Yes,
Can be in.
Yeah, actually, that's a good point.
absolutely.
So the software on the Mac is pulling off that GUI and the Flex. So that the Flex doesn't care what kind of computer.
Exactly. Exactly right. Yeah.
So the only. Go ahead, I didn't mean to.
I just can say, people spend $400, why not?
Oh, yeah. Yeah, we have a guy, Bill Cody, K3CDY. Yeah, William Cody's really his name. And he has a Mac and he has a Teensy Maestro now and number 3. Yeah. And he's the third
So-
one to build.
So since you started this, I've been following it on the Flex forum.
Yeah,
And the thing that now that I've seen it, I have a very different view of it, but I kept saying to myself, when are you gonna add a pan adapter? So that I never, huh?
no, not gonna happen.
I mean, it's so cool that it's like, no, I just want the whole thing right there.
Yeah, yeah. Well, we'll talk about that, so so stay on the edge of your seat. Yeah,
I just Googled, what about these little ones here?
I can understand.
I just Googled the thing and XDF radio. What are these about the little ones? It's like on the front there.
Oh, no, okay, those are software defined radios. So you're looking at dongles. Right, those are, if you want to get in very cheap and understand software defined radio receive only, that's a great way to go.
Yeah.
$20-30. You'll be able to do a lot with those.
All right.
Yeah,
I found one for $50.
Interesting, but is it for me? So that be a way to kind of,
Yeah.
you can, yeah.
oh, okay.
Yeah.
Yeah, I found one for $50 at a swap meet.
Yeah,
Yeah,
yeah, you can get it much cheaper than that.
yeah, I believe it.
They won't have very good performance necessarily, but in terms of understanding, yeah, what you're trying to accomplish, it's not a bad choice.
What's the best with the little SDR, like for a couple $100? I'm trying to think of the name of one of those.
Well, as we say in the business,
AirSpy. AirSpy is one of them.
yeah, I have a SDR Play,
Yeah,
the
that's
other
what I
one I'm
got.
trying to
works
think of.
works pretty
They're
nice.
really cool.
Yeah, I use that as
The
a,
software seems like it's come a long way.
it has.
Yeah, it
And
has.
I use that as a pan adapter for my K2.
Mhm.
Oh.
And then in the K2, I tap off
The IF
and
thing.
no, the RF
Oh,
at the TR switch so that I have a way to listen to it.
Yeah,
oh, that's interesting.
Yeah,
I use mine as an APRS digipeater.
right. Yeah,
Just connect it to a Raspberry Pi and an antenna, and
off you go.
Yeah.
Yeah. Yes, go ahead. Yeah.
They come with an enclosure.
Yes, so I don't know about the kit that, the question was for people on the listening, will the kits come with an enclosure? So the kit made by G7 UFO, he builds the enclosures. He 3D prints the enclosures and that's part of the kit. Bill K9HC out of Katy, Texas, is planning on kitting these, but I don't know yet that he's including the enclosure with that kit or not. In any event, these enclosures you can buy on Amazon for $18. So they're not terribly expensive and
Wow.
yeah, and they're easy to work. They come with an aluminum front panel, and my original one, this is the front panel that came with it. And then I cut it up myself. If you buy the board sets, if you buy this $18 box and then buy the board sets from JLC PCB, then you get the aluminum that looks just phenomenally nice. Simon just did a bang up job on that.
Why? To make it brush template.
Yeah, you could do, but you can also get this just in the same PCB material, but black.
Yeah.
Or any color you want, really, or whatever colors they offer for their PCBs. There won't be any traces on it or anything. It's just a plain PCB board with no copper or anything, but painted in silk screen, and that's a little bit cheaper. That's about half the cost of this. I believe these were about $15 in low quantity, and these are $7 or $8 in low quantity, something like that.
Oh,
Oh,
probably
here he is now. Hi, Simon.
head over to Simon, right?
Yeah,